Hello everyone. Today I'm going to show you how to integrate with U-Substitution. So here we have this really complicated equation. We can see this is 3x squared plus 2x times e to the x cubed plus x squared dx. If you look closely at the power of e, you should probably recognize that x cubed plus x squared is the integral of 3x squared plus 2x. So here's what I'm gonna do. So first, we're gonna set u equals x cubed plus x squared. And then we take the derivative of u, which is du over dx, and that will be 3x squared plus 2x. And then you can see 3x squared plus 2x is the one we have in our original equation. Now we multiply dx on both sides of this differential equation, and then dx on the left canceled out, and we have dx on the right. So with the value of u and du, we can now rewrite the integral with e to the power of u times du. The integral of e to the x, or e to the u, is the same. It's still e to the u. And now all we have to do is plug in our u values back to our integrals. So it's e to the power of x cubed plus x squared plus c, and that will be our final answers. How easy is that? And here we have another integral that we can use U-substitution to solve. And before we go in, I just want to mention that you can always take out the constant and put it in front of the integral, as I wrote over there. So first step is to identify the value for u. And since the only numbers that in this integral is 7x plus 9, and you can set u equals to that. And the derivative of u will be 7 times dx. Now we plug in u and du back into the original equation, and then you should probably find out that because there's a 7 times dx, that our new integral is 7 times larger than our original one. So what I'm doing here is I just multiply 1 over 7 outside the integral to make it even. And we know that square u is equivalent to u to the power of 1/2. And then we just rewrite the function and then applying power rule. And you end up with 1 over 7 times 2 over 3 times u to the power of 3 over 2. And now we plug in the value of u, which is 7x plus 9. And we end up with this equation, always plus c at the end. And then that will be our answers. Sorry, I just made a mistake. That should be 2 over 21. Always remember to check your answers. Here we have another episode of U-Substitution. Just look at the denominator of this equation. You can see that x to the 4th plus 7 is bigger than 4x cubed. So you always want to set the value of u to the one with bigger power. And du will be equal to 4x cubed. And you can see that that's the numerator of our equation. Sorry, I just couldn't write. And that's 4x cubed. And don't forget the dx's. And so all we have to do is rewrite our integrals with u and du, which in this case is du over u, or 1 over u times du is the same. And the integral of 1 over x is ln x or ln u, and don't forget the plus c at the end. Sorry, I just forgot to plug in the value of u, but you know how it works, so just remember always to plug in the value of u back to your integrals. And here we have another integrals that we can use U-substitution to solve. And the first step is always to set the u values. So I put u equals to ln x, and why? Because, just think about it. You can now set u equals to x, then du will be equals to 1, and there's no way to solve that. And now we have our u and du, so all we have to do is rewrite our equations using u and du, and that will be pi. We can just put it in front of the integral. pi times the integral of 1 over ln x times 1 over x dx. And then you could recognize that that's du and du. So rewrite again, pi times the integral of 1 over u times du. And that's really easy to differentiate. It equals to pi times ln u with absolute values plus c. And don't forget to plug in our u values back in. So we have pi times the ln of absolute value of ln x plus c. And this will be our final answers. And that's the end of U-Substitution. I hope you guys learned a little bit. Sorry I'm a bad teacher. Please ask Mr. Ta or your math teacher if you have any questions.